Can you all hear me fine?
Yeah. Yep.
How about you there in the back? Okay, great. Thanks, Matt. All right, so talk was originally entitled How to Build a Better SRE Team, but I struck the team off because I wasn't able to add some of the additional sort of material I wanted for that. So this is going to be more about focusing on the skill set and sort of inclinations that an SRE should have. This talk could be relevant to people who are thinking about becoming an SRE, and also to people who are looking to form an SRE group, you know, reorganizing their support structure in that way, or else people who already have an SRE team is just trying to get a better foundation on what skill sets that they should train up on, or else find candidates that have that skill set to hire. So just quick introduction. I worked for Sony Gaikai. We were a startup that was acquired by Sony a couple of years back. We developed the PS4 Remote Play, which allows you to to stream a video game basically from your PS4 to a mobile device like the PlayStation Vita, or else to your an Xperia phone. That's just an offshoot of our original technology, which is the ability to do an interactive stream to any sort of video content. So our current biggest service is PlayStation Now, which allows you to interact with a PlayStation 3 game currently, but eventually possibly other game content as well, via your game console, or else any of the select TVs that support PlayStation Now. So really it's just a thin client that, you know, you have a video stream that comes from servers that are rendering the game content on our end, and then you're able to play that content by sending input back the other way. Because of that, there's a lot of technical constraints in order to provide a good quality experience that goes beyond what you need, for instance, for Netflix or Amazon Prime, where the content is non-interactive and you can basically statically cache a lot of the content in that case. In this case, all of it's kind of real time, more or less. Anyways, that's all I'm going to say about Sony until we get to the last part. This talk really just represents my own views. It has no, it's not an officially supported set of opinions from Sony or anything, but it is colored by my experience working for Gaikai and for Sony. Okay, so agenda. I'm just going to go through a quick introduction about, you know, what does it mean to be an SRE, and then what's a common toolbox or tool set that SREs have, and concepts that they should be familiar with, and also application stacks they should be familiar with, and other abilities or inclinations that they might have. And then a quick set of resources or links, and we can do question and answer after that. That doesn't mean you can't ask questions during the talk. Just, you know, raise your hand or speak up if you want clarification on anything. Okay, so what's an SRE? I think I actually did not say anywhere here in my slides spell out the term. SRE often stands for Site Reliability Engineer, as Google puts it. At Sony, we use the term Service Reliability Engineer because to us, it's PlayStation Now is a service that happens to rely on sort of network enabled components, but it's not what we typically would call a website. So hence, I like the more general term service reliability engineer, because what you're really thinking about is a service that a customer has paid for and wants a good experience from. So as an SRE, what does reliability mean? Well, usually I think of it in three components, and that's availability, scalability, and security. And all those relate to just, can you keep your service up? So availability is just that. It's whether or not the service is up from the perspective of, well, multiple perspectives. You have the whether or not your application can reach your site and get a status of whether whatever content or ability that your service is providing is actually available. And then scalability is kind of the long-term trend of whether or not you're able to provide your service to more customers as your service grows. And then security is the ability to keep your service up even in the face of malicious actors on the internet. This is, of course, assuming that your service is something that you're providing on the internet. In some cases, it might not be. Maybe it's just internal. But even then, you have to worry about things like whether your service is being accessed by people who are authorized to get access to it. Whether or not it's just the paying users that are able to access it, or are other people able to. Anyways, in addition to the actual reliability and day-to-day maintenance, the SRE role often involves managing deployment and changes. The main reason for that being that usually there's some sort of discrete change in your reliability when you're upgrading from one version of your software to the next version of your software. So it is usually a good idea for SRE to at least be aware and also be able to measure metrics based on whether or not you've made a successful deploy or a successful upgrade to some servers or network in some cases. Another common aspect of the SRE role is troubleshooting. Often you're presented with a situation where something's not working the way you expect it to, and you need to get in there and start looking at the system and figure out what's going on with it, and be able to come to some conclusion on how to rectify the situation. So this comes in two sort of flavors. One is when you're on call and you're being paged with some very specific alert because of your monitoring software, and the other situation is just you might be troubleshooting even just a pre-production version of your software and figuring out why is this not behaving the way that it's supposed to. And this also happens to the software that you're using to maintain your actual service. You'll have a lot of satellite services for monitoring and also for data aggregation. Finally, the SRE role, one of the expectations of a senior SRE is to influence the architecture and implementation of the application stack. You may not necessarily be directly involved with the development and implementation of the service itself, but you will often be able to, often should, it certainly helps in being able to proactively define an architecture of how the software should work in order to prevent failures that might cause the system to be less reliable. and that's the main reason for being involved in the architecture and implementation. I should speak a little bit more. In a smaller company like a startup where of 10 or so people, you can think of the SRE role as more of a hat that you put on rather than an actual position. You might be a developer or somebody who has just a lot of technical knowledge and is setting up certain aspects of your startup, but somebody should be keeping the eye on the reliability of your service. So it might not be that you're doing SRE full-time, but that's what the role involves. Related jobs. System administrator and web admin are very common roles to transition from to the SRE role. And there's, obviously there's a significant overlap of skills. I would say the focus is slightly different. For a traditional sysadmin or web admin, you're usually more concerned with a single aspect of your system, for instance, the operating system or the hardware for a sysadmin. And then for a web admin, you might have, it's kind of more of a historical role where you're involved in administrating the web infrastructure, so like Apache or sort of the PHP and database builds on your system. A release engineer is another role. Release or engineer, or forgotten the other term I was going to use for it, but basically somebody who is involved in the building and that's right, release or integration engineer. Somebody who's involved in the building of your software and packaging of it into the form of what we would traditionally call a release, and might be involved in also checking the quality of that release in order to make sure that it's actually okay to deploy or upgrade to. Often release engineers are underappreciated. They're usually another sort of category of people who are jack of all trades or Jill of all trades, where they don't have just one skill set, but they have to have many in order to assure that the software is working the way that it should. Finally, software engineers and developers also might transition to the SRE position. Most commonly, this is in the form of some sort of DevOps position or role where, especially in a startup again, you don't have that many people to cover all things, so you end up doing more than one job. So why are SREs even relevant? One of the things is that traditional three-tier support for web services as we know them today, and also just internet services in general, are not necessarily the best fit. The reason for that being that your internet service, say Netflix or Google search, are expected to be online practically all the time. If they're not online, at least you're expected to get a ping back saying, hey, our service is having problems right now, please try again later, if you can't at a minimal level. And the traditional sort of three-tier service that a sysadmin would follow is, you might have a NOC that monitors things and or a customer service representative who would respond to actual customers and then open tickets based on that. And then you'd have another triage engineer that might be involved in trying to figure out what the problem is, and then finally pass it up to a third-tier engineer who would have like, kind of like the fallback for any not unknown problem that somebody has to actually dig even further into. You don't have a run book for it. So that's great for when you have a high volume that you need to process of issues, but not great for the immediacy of response or the latency of how quick do you go from start of recognition of the problem to resolution of the problem. So typically with SREs, you're going to try to do more automation, and then finally go directly to an SRE for, hey, the automation cannot resolve this issue. What's going on? So the other thing about SREs is it's great for people with who like challenges. Since you're involved in the reliability of the whole service as a whole, you might touch upon various aspects of the system from the very low level in terms of like how the clock is working. Like if there was an issue with the kernel that caused, say, your system clock to be on the fritz and make your service, make all your Java services fail, all the way up to like, what is the proper memory tunings on a JVM in order to get the best performance out of the system. So in an organization where you have people who are talented, you want to be able to allow them the maximal amount of freedom to be able to provide to be productive in ways that they can be. And SRE does open those possibilities up, where if you're pigeonholed as a sysadmin or a web admin, then your role is a bit narrower. Similarly, you get a lot more cross-disciplinary exposure. So as an SRE, you may have a particular background or focus of knowing about operating systems or knowing about web development or JavaScript, etc. But you get the chance to kind of broaden that knowledge. So this is one reason why you might personally pick to be an SRE if you want to transition from one role to the next. It might even be as far as going from somebody who's more application oriented to doing some sort of network design or network architecture. All that's possible, with an SRE background. Finally, SRE role tends to reward excellence. At most of the companies that currently have service reliability roles, the pay scale, tends to be a little bit higher than you would have for a typical system administrator or web administrator, and even some developers. Though developers have a much wider sort of variability to how much they get compensated for, so I can't say for sure. But in general, you'll be rewarded in various ways, and you'll be recognized for it. Okay, so enough about that. Let's get into sort of what tool sets a typical SRE should have or may try to attain in order to be better at being an SRE. So common languages that you should have exposure to are C or C++, and Java and Python, or the three big ones, I think. The reason I picked these are because they they're the most common in the open source code that is out there and available. It's without question that we're running Linux on most of the operating systems that are used for serving services out there. I mean, there is Windows as well, but even that, either way, the base level operating system is written in C. So having some knowledge of C and being able to understand what's going on at the very lowest level is useful. And Java is just been used a lot in many sort of enterprise and also other Apache sort of open source projects that are being used as sort of the building blocks for all of the sort of value add services that we have today. Finally, Python is, in my opinion, a great scripting language, and also is being used as a reasonable sort of glue layer for a lot of applications today. I would say maybe in some of the companies that originally started with Python, they're moving towards newer things, but it's still a great language to know. And of course, for future proofing, and also for very specific problem domains, languages like JavaScript and Ruby are great to learn. JavaScript being heavily used for web development, and Ruby for like configuration management. So those are also very useful. So what do I mean by knowing a language? There's multiple aspects. There's the ability to kind of read source code. That's usually not so hard once you get used to the basic syntax of it. There's also the writing of it, so you yourself being able to make modifications to source code in those cases where you think there's a bug in the software is also useful. But in addition to that, there's just the sort of familiarity with running and debugging the software. So that one's not to be underestimated. For instance, with C and Java and Python, these are commonly deployed in very specific ways onto any service that you run. Usually there's some sort of packaging involved. In the case of C, you need to make sure that certain libraries are, if you're using shared libraries, then you need to know how those shared libraries interact with your runtime environment. So stuff like that can prevent a program from running, even though all the bits are there that should be there. They might not be ordered in the way that you expect them to in order to actually get your service up and running. And in addition to that, when you're trying to debug it, you're going to run into some other obstacles. Maybe you need to add additional flags or additional, maybe like be able to run with certain environment variables and stuff like that. So knowing these languages isn't just about being able to read and write code. It is also about being able to actually operate the code and the instances of the actual code as deployed on your servers. Sorry. All right, so let's get into some actual tooling. Some commands, I just put out a few of them here, but I think they're kind of a representative set of tools that SRE should be familiar with. The reason why I mentioned such trivial tools like ls and find is you can't find anything on the system without them. And in addition to that, using grep, cut, tr, awk, sec are very useful. Who here is familiar with JQ? Anyone use it before? Yeah, so it's mostly people from Gaikai and round. Yeah. So it's not my favorite tool in the world, but in this day and age where there's a lot of JSON sort of file format stuff, it is pretty useful for being able to extract stuff out of that JSON and select very specific fields in it. Yeah. Yeah, the documentation is not the greatest. Maybe it's something somebody could improve. It is open source software. The reason why I mentioned Xargs here is it's like a great power tool for when you need to convert a lot of arguments into a lot of commands. Similarly, Bash, if you know how to do Bash scripting, and even just being able to do a simple while read or for loop will help you get things done faster, which is important when you're trying to fix a lot of stuff. Who here is used a poor man's multi-server SSH by just scripting something using a for loop and SSH? Yeah, okay. So this is the right audience for that. And of course, cron lets you schedule things, and there are a lot of different flavors of cron out there. So I would recommend being very familiar with whichever cron you're running on your systems. The reason why I put DF and DU there is because it gives you a basic understanding of how your storage is being used. Can anyone explain to me what the difference between DF and DU is? Sorry? Yeah, so from the output, DF and DF may give slightly different output than DU in terms of the units it's using, but more fundamentally than that, DF is telling you what the file system knows about disk usage, whereas DU is telling you about the directory, the actual usage from the perspective of the directories that you're searching or recursing under. And the reason why that matters is that DU will not find hidden inodes, whereas DF isn't based on inodes, but just based on block accounting. Okay, anyways, next page. Knowing sort of how to look at the operating system is important. So you have various tools. Everyone's familiar with TOP, I assume, but in the same vein, there's tools like VMstat, IOstat, and DStat, which can give you more detailed information about specific resources that the operating system accounts for. And in addition to that, if you're looking at network access, I forgot to put, in addition to NetStat and LSOF, there are some other tools that can give you information about what the current primary usage of your networking bandwidth is as well. But basically, NetStat and LSOF are a good place to start with that. In addition, tools like strace and ltrace can tell you things about processes and what they're up to. And then TCP dump is a great tool for troubleshooting the network interaction of various things. Who here has used TCP dump to troubleshoot anything? Yeah, okay, so I'll just skip over this stuff. All right, so familiarity with GDB and JStack and PDB, that's in parallel to sort of the three languages that I mentioned before. So like GDB is great for debugging C, assuming your code was compiled with GCC or whatever. JStack is useful for giving you some insight into what your Java processes or Java threads are stuck at. And PDB allows you to do some debugging of some Python code. This by no means is a complete list of debuggers out there, but if you're going to study any debuggers, I think those three are a great choice. For profilers, there's oprofile, which is it's useful. It has its numerical sort of inaccuracies in terms of the way it does its sampling. dtrace is a great tool. You'll hear Brendan Gregg harp on this a lot. Oh yeah, I forgot to mention. So that website at the bottom, many more. Brendan Gregg's website has a great set of tools for system introspection at more levels than you would know what to do with. But I would definitely recommend looking at it to understand what it is that we are able to know and what it is we're not usually looking at. So in addition to that, Brendan's a great fan of dtrace. Unfortunately, because of the software licenses, it's not the best compatibility with Linux. But Brendan's also working on some wrappers around ftrace and perf events that allow you to figure out what's going on Linux with the same degree of clarity as dtrace provides for other operating systems. Anyone used dtrace or ftrace before? A few? Yeah, okay. And then finally, there's paramount profiler, which if you Google it, will give you a very small, I think, either Perl or Bash script that basically just does a periodic GDB stack dump, and then processes that with awk in order to give you a frequency count of what the most common stack trace is, which is useful sometimes for figuring out, if you have nothing else, it can tell you like what line of the code you're running right now, all the time. So for the sort of kernel and hardware level, you have these tools. Anyone use LSHW before? I think it's kind of more helpful than LSPCI for certain things, but LSPCI will tell you some more PCI specific information in some other cases. Modinfo, lsmod, modprobe, insmod, just familiarity with how to load and maybe reload kernels might be important, depending on what type of application you're dealing with. In today's sort of cloud and web world, maybe you don't have any specific kernels that you care about, but in some specific types of jobs where you're getting into something more low-level or hardware-specific, that you definitely want to understand how that works. So let's talk a little bit about host networking. Anyone familiar with the IP command? Okay, so about half of you. So I typed this wrong. It should be ifconfig, not ipconfig. I don't know. That was a total brain fart on my part. It's not because I'm Windows centric. It's probably because I typed IP first. But so while ifconfig allows you to configure mainly the interfaces on a Linux system, IP is actually the more up-to-date tool that allows you to configure a number of different things, including IP link will allow you to configure interfaces, IP adder will allow you to add addresses, and then IP route will allow you to configure routes. There's a few other things where you can set up routing tables and other things that are in the newer Linux IP stack that ifconfig just cannot even touch and will sometimes give you the wrong answer for. So you should probably get used to using IP on Linux, because ifconfig is somewhat deprecated at this point. Knowing how to do static routing is very useful for various environments. Knowing IP tables, both how to configure firewalls, that's critical for security, but also doing NAT, that's I have limited experience with this since it's been a while since I used AWS, but NAT and firewall, the NAT aspect is somewhat useful when you're trying to configure a VPN or something like that, or just getting around a certain layer of networking when dealing with sort of cloud infrastructure. Just because in general you're dealing with an environment that may not be fully on the internet, so you need to have some understanding of how to transform your IP addresses to ones that can be routable on the internet, assuming you're providing an internet service. just the basic notion of how to do a VIP failover. It's not the basic way to do VIPs, using something like HA Linux, is not terribly hard to understand, but just familiarity with some of the problems involved with that when you can have sort of IP collisions because both both servers are trying to activate the VIP at the same time, stuff like that, and how to troubleshoot it is very, very useful for services that you're trying to maintain in an HA fashion. And then finally, bonding. In a lot of cases, especially if your service is high bandwidth, streaming obviously is one of those cases, you may have to deal with being able to aggregate multiple physical links into one virtual link in order to be able to provide enough bandwidth from your server. So there's been a few SCaLE presentations on bonding, so that's all I'll talk about it. But you can look them up online. Bonding? Yes, yeah, that's true. The other thing that bonding provides is redundancy. So you're less likely to have a particular IP address fail just because like one particular network port on your infrastructure fail. But you're probably also doing redundancy on a multi-server scale as well. So it's not as big of a win. So just be familiar with the different levels of the OSI stack and how they're supposed to interact. Anyone not familiar with the OSI stack here? Okay, never mind. Knowing sort of TCP and UDP, what the differences are, why we have UDP packets for certain things and why TCP is used for other things, is useful. Can anyone name a protocol that uses both TCP and UDP? Yeah, that's a very good one. And there's specific reasons why TCP is used for some parts of it and UDP for others. SNMP, understanding what's useful about it, but also like how it actually interacts with specific application protocols is important. So in particular, there are certain SNMP packets it's probably okay to block in certain directions, but there are other packets that are probably very bad for you to block. Who's familiar with the acronym PMTUD? What does that stand for? Yeah. So path MTU discovery. That's the ability to figure out what the MTU, or the maximum transmission size, is along a particular network route, is critical for functioning of certain types of internet protocols, especially ones that don't like to fragment. So if you're blocking, forget the exact protocol number, but one of the SNMP packet types, if you're blocking that on the reply path, that means you're preventing path MTU discovery from working. And that might crop up in some problems that you have to troubleshoot, especially if your network clients are willy-nilly all over the place and not just in your own network. SCTP is not a very well-known protocol yet, but it's starting to be used a little bit more in certain worlds, and it's sort of a TCP alternative. I don't know. Is anyone using SCTP at this point? Yeah. Okay. So it's sort of future-proofing. IPv6 also, we keep saying that IPv6 is coming, and I bet most of us haven't fully transitioned to it. But inevitably, I think that'll become more important. application protocols, just dashing out a few ones there. Because most web services out there are based on some flavor of HTTP, it's very useful to know your 200 response codes versus your 400 response codes versus your 500 response codes. Sort of understanding the basic handshakes and how they work. And now we start having like for a while people were using Speedy, but now like HTTP 2.0 is coming, so that's another protocol that a lot of us will probably be getting to know better as it starts being deployed more. DNS is without doubt very important for you to understand, just from the perspective of being able to do proper domain registry, to understanding what security is involved in it. And finally, NTP, sometimes you'll need to troubleshoot why all your logs are off, and why is it's another protocol that's out there that does not have the normal sort of server client model, because it does sort of peering. So it's useful to understand that, to have a different conception of how network protocols might work. And finally, DHCP is another one that, knowing it well, is useful just from a bootstrapping perspective of being able to do PXE boot, all the way to like being able to troubleshoot why your addresses aren't as stable as you expected them to be in your cloud infrastructure. Same, and then as far as routing protocols are concerned, that's probably a little bit more in depth of knowing like how these protocols work. But there's some really interesting things you can do with BGP, for instance. So has anyone done ECMP, which is equal cost multipathing, multipath routing, in order to serve the same address? Or another term that you might have heard before is Anycast. Yeah. So Anycast usually happens at the routing layer, and often like BGP is one of the protocols used to do that. MPLS is commonly used if you've got some involved network backbone that you want to make redundant. You basically, you're doing a virtualization on top of the actual physical layer by using MPLS. Other things that are useful to learn from a networking perspective are just knowing what's usually provided by a managed versus an unmanaged device. So in terms of managed flavors, Cisco and Juniper are pretty common, and there might be some specialized devices like load balancers or caching devices. I couldn't think of any good caching devices off the top of my head, since I don't have that much experience with them. But for load balancers, F5, Big Iron, it's Big IP. Damn it! I really need to fix my slides. And NetScaler and Barracuda, those are some of the common ones out there. Personally, I'm most familiar with F5, but understanding what a hardware load balancer provides on top of what you could use something like HA Linux or some of the other software load balancers out there, or just even like Squid, to do something similar at the software layer, but you get vast performance improvements because of the hardware acceleration in these load balancers. So it might be a useful thing to know. Okay, so what sort of concepts also might be useful for SRE to know? Familiarity with the operating system, know what a scheduler does, what the drivers are really there for, knowing sort of the difference between user versus kernel space, and finally, like being familiar with virtualization is very useful for all of the above. Like if you've played with virtualization, KVM or Xen or even VMware, then you have a better understanding of what's that thing that's sort of the hardware versus what's the kernel versus what your application is actually running. I think some of the most interesting sort of technology developments today are due to virtualization, and you could say that the PlayStation Now's game streaming service is sort of a virtualization technology for game consoles. And I'll leave it at that. I can't really explain too much about what goes behind it. Some concepts that might be useful from a performance perspective. I should have just said performance rather than queuing theory, but queuing theory is sort of integral to it. Who here is familiar with Little's Law? Okay, no one. All right, it's a very simple principle. It's basically your load is, when you're close to equilibrium, it doesn't have to be full equilibrium. Your load is equal to the arrival rate of your users times the service time that the users take in order to complete whatever request that they made. And that's sort of the number of concurrent users that you have on the system at the moment. So if you know two of those variables, you can kind of figure out the third. And knowing all three can kind of give you a backup check of what's going on with your system. If those three are not close to equal, it probably means your system is out of equilibrium. And what I mean by out of equilibrium is possibly your service time is changing, so your requests are taking longer and longer, or your arrival rate is changing rapidly, in which case maybe it's because they're getting a whole bunch of 404s or 503s on your system, and as a result of that, you have a lot of people trying to hit your web service, but very few people are succeeding. So knowing Little's Law can actually help you very quickly determine is my system in a stable state or not. And we use that at Gaikai in a slightly different way, because our users are users that are streaming for a very extended length of time. It's not a web request, but the law still surprisingly works. So it's a very adaptable law, in my opinion. Universal scalability law. I forgot to reference that. This is Neil Gunther's website, but basically at that site he outlines a more involved equation that I didn't figure out how to post here on using LibreOffice. But basically the equation has three factors in it, and in theory applies to any sort of software system in terms of the concurrency, the serializability, and the coherency. And basically, you can characterize any software system this way in theory, if you have if you can drive the traffic properly to it in a load test, and kind of arrive at a conclusion of, is your software behaving in a sort of linear way or sublinear, or like really even more poorly than that, it starts to degrade faster than you expect it to. So I would definitely recommend checking out this site. I would show you more about that right now, but I'm running short on time. Okay. Another thing, I mentioned cloud computing a few times, or AWS and stuff. So a lot of people have different definitions of cloud computing, so I'll try to give my brief one. To me, it's mainly about the difference of scale. So in the old days, the main concern of sort of system administration and what you would call service reliability back then was high availability. But today, what the main thing people are trying to do is scale their services up in as linear a fashion as possible. And so that's why like AWS markets most of their services as elastic whatever. So you've got elastic IP, you have EBS, elastic block storage, and I forget what they call their computing layer, but it's like elastic compute or something like that. And really, the way they do this is, on their end, they do all the nitty-gritty of being able to automate a whole lot of low-level configuration, and then just provide you an API to do that, to do whatever operation you're trying to do with. And so you've got basically two sides to the elastic computing. You've got the automation layer in the background, and then you have the API layer, which is what is presented to the user. And this is why I'm not sure like solutions like VMware are exactly what I would think of as like they provide a cloud computing sort of solution these days, but a lot of it's tied around sort of a GUI approach, which means that what you actually end up with is what I call an enterprise approach, which is, in the enterprise approach, usually a lot of stuff is done by deployment through a GUI or configuration through a GUI or even installation through a GUI. Who here has had to deal with the Oracle installer using, redirecting X in order to get it to install? Yeah. So that's kind of typifies what I think of as sort of the enterprise approach versus the cloud approach. Cloud approach, you're looking for doing things in as repeatable and automatable a fashion as possible. And that's sort of the mindset you want, especially in an SRE role. But I think even if you're a developer, that's what you should be looking for, rather than something that's push button, as in you literally have to push a button in order to get things working. So next topic, distributed systems. So there's the fallacies of distributed computing. I won't get into all of them here, but look it up. Basically, the most common ones are that the network is reliable and that the network is secure. And it's not just theoretical. There's a lot of evidence that our real software systems, especially cloud systems, I think like the fallacy that it isn't listed at that Wikipedia page is basically the cloud is reliable. You should not expect the cloud to be completely reliable. You should understand that it has even more complex failure modes because it is a distributed system that has many, many layers in it. Afer, if you've ever heard of him, has posted a blog of some of the very common AWS, Google, and other outages, and sort of the various reasons for it. All these just relate back to Murphy's Law, in my opinion. It's just like anything that can go wrong will go wrong. It's not strictly true, but if you run a service for long enough, you will see many more failure modes, and with enough customers in particular, you will see more failure modes than you would have ever dreamed of. And it's very humbling to be in that position, to be able to see all this go on and try to fix it. It's like, every day is a new problem. And I think that's something that you have to get used to in the SRE position. So what can help with that? In the case of network is not reliable, there's been a lot of research, but it kind of boils down to sort of protocols for how you deal with that. They're basically heuristics. The two generals problem is basically a proof that coordination is hard, and the network is not secure is the problem of that is broken down in basically the mathematical sort of analysis of that is in the Byzantine generals problem, and basically the result of that is that you cannot have a reliable coordination between multiple generals unless not all your generals are traders, or less than a certain fraction of your generals are traders. And another common, not completely proved result is the CAP principle. Who's familiar with the CAP principle? Yeah. So that's basically the statement that consistency, availability, and network or partition tolerance, network partition tolerance. Those three properties of your system, if you have a distributed system, you can't maintain all three. You can kind of pick two of the three as sort of your priority. And in addition to that, you're not really supposed to pick the case where you exclude partition tolerance. So a lot of the software, distributed system software out there now that is open source at least, can be classified into two of those categories. It chooses consistency and partition tolerance, or availability and partition tolerance. So those categories are usually called CP and AP for short. And that includes some of these applications here. So so you should have familiarity with these sorts of applications, in my opinion. These are the ones that give you the biggest win in the open source world right now. You're without doubt going to have to deal with applications that are written in-house that sort of perform similar sort of operations. But this is your best bang for the buck if, say, you're doing a new startup. So there's no reason to rewrite your own web server. Apache and Nginx are very common web stacks to use. I think Nginx is starting to become more popular just because it is proven to perform better under constrained resources and with more users. MySQL and Postgres are very common ACID databases to use, and I think they'll continue to be used quite to varying degrees, despite the fact that there's reliability issues, for instance, with MySQL, depending on how you deploy it. You can still make something reliable by structuring it properly. Hadoop and HBase are some of HBase is sort of the database on top of the Hadoop file system, and that's increasingly being used by various places that have to deal with large volumes of data that just you can't fit onto a single file server. So anywhere where you're dealing with big data, they probably have heard of Hadoop before. And then Zookeeper is another Apache project that is used for distributed systems coordination. So sort of like the result of all this mathematical or computer science work that was done is basically a few different protocols, including one called the Paxos protocol, which is not what Zookeeper implements, but it's analogous to that. Zookeeper has a protocol called ZAB, which I think stands for Zookeeper Atomic Broadcast, which is basically solving the problem of being able to keep data updates for in sync across multiple servers. And this is supposed to be for small-sized data updates of just like who's in charge right now, and who has the latest version of X and stuff like that. And that's basically Zookeeper can be used pretty flexibly by any distributed system that you're trying to build, and it's in fact used by the Hadoop 2.0 and also HBase, I think, used it from the early days in order to do its distributed system coordination. Other systems that run across multiple servers in a cluster configuration are Elasticsearch. It's a very useful service if you want some sort of search engine for your data store. So it's slightly different than the Hadoop model, and but it's being used very commonly for log aggregation now, in addition to Logstash and Kibana, which is a great front end for doing log searching in Elasticsearch. So like, I think there's probably a booth upstairs for ELK, or ELK is the acronym for that stack of Elasticsearch, Logstash, and Kibana. And finally, Kafka and RabbitMQ. They're not exactly the same sort of beasts, but they're basically very high volume data pipelines for you to sort of ship data from point A to point B, sort of in a more reliable fashion. So like, you need to kind of keep the data queued up somewhere before your workers can process them. Then Kafka or RabbitMQ might be a good solution for that. RabbitMQ, I think, has been used in some financial companies. Kafka is being used for by LinkedIn, and it was developed by LinkedIn for basically their website monitoring and sort of data feed aggregation. So these ones are probably the most useful. I'll skip over this, but there are other NoSQL data stores. All of them can be categorized into that CP or AP sort of flavoring. The ones that I list here, Redis, MongoDB, and Cassandra, are some of the more well-known ones. In particular, Redis and MongoDB are easy to deploy and play around with. And then a lot of those applications that I just named have what are called RESTful or CRUD APIs, create, read, update, delete sort of APIs. Basically, they're just basic HTTP to URLs, and there isn't necessarily a lot of structure behind them, but most commonly they either take some sort of XML or JSON data payload along with, and then you basically can post documents to Elasticsearch, for instance, or post configuration changes to Elasticsearch using a curl or a web browser, depending on what you have configured. So these days that's getting more and more useful, just to be familiar with that. SOAP and XML RPC are kind of the old flavor of HTTP-based web APIs. A lot of people recognize they're providing more straitjacket structure and boilerplate than is strictly necessary. So that's why people are going towards RESTful type of APIs. That said, there are a lot of cloud providers out there like AWS who are still using one or the other variant of SOAP or XML RPC, and in order to actually request, virtual machines or configure DNS entries. So it's not that much harder to learn than RESTful APIs, but it's harder to use on the command line. Usually you have to write some Python script or something to do something with it. Finally, configuration management, having some notion of what it's about and being familiar with at least one of like Puppet, Chef, Salt, or Ansible, take your pick, can help you a long ways towards automating a lot of deployment. That said, I wouldn't necessarily say that any of those solutions right now scale up to the degree that you might need them to, depending on how large a deployment you're looking at. So I think CF Engine claims that they can do like 100,000 servers, but I think any of the other configuration management systems that I've seen so far, probably the largest installations are an order of magnitude below that. That said, CF Engine is not that fun to learn from what I understand. You're smiling there. I'm going to have to talk to you later about that. Okay, enough said. Okay, I'm really almost out of time. Oh, shoot. I'm sorry. I'm actually over time. Other abilities and traits. Communication is very important to the SRE role. The ability to write concisely in emails, not bury the lead of what you're talking about, and also the ability to avoid flame wars while you're trying to discuss something important is pretty, you don't want to waste time doing that. And then finally, like interpersonal communication, like the ability to interview well, on both sides is important. So like you're not going to get the job unless you're able to understand the format of an interview as an interviewee, but also as an interviewer. This role is so sort of requires an intersection of so many skills that you're going to have to figure out ways of being able to ask questions and infer answers based on what people are saying much more quickly than you would for some other type of position. In a lot of jobs, like a developer, you get asked one programming question and maybe one design question, and if you solved it, then that's that. But SRE, there's a lot more to cover. Finally, troubleshooting. Knowing different troubleshooting methodologies. The use method is a great one for specific sort of problem situations with services. So that's sort of Brendan Gregg's talk from last year, I think, was about the use method. Basically, it stands for utilization, saturation, and errors. If you look at those three things first, then you might find the answer quicker, and something that you can basically try to build all your monitoring boards around. Like you can look at utilization, for instance, is typically CPU utilization is a good example where that's why you look at top, is to look at that utilization. Saturation, one way of looking at saturation is to see what your load is. So remember I talked about Little's law before. You can infer your load from that. And also your load average on your Unix servers, same concept. And then errors, that's just whatever error logging you have. You might even have specific error metrics around things like, very common one is like on your network interfaces, you might want to know that you have a certain error statistic around that. You might be able to track how many errors you have in your Java application for how many times it failed to do garbage collection or allocation of memory, stuff like that. Anyways, more general method for troubleshooting, just scientific method. You come up with a hypothesis and then you test it. And finally, how to solve it. It's a book by a mathematician called Polya, but it's an entertaining read. But the basic concept comes down to examine your assumptions, form a model of what's going on, and then formulate a solution, based on that model. Other abilities that are useful. I couldn't think of a good name for this one, so I'll call it dispatching. It's the ability to identify the party that a problem should be, has the domain expertise to solve the problem. So you as an SRE may not have the full depth knowledge in order to solve a problem, but you're going to have to kind of forward that problem to somebody else. And knowing what everybody does at your company is very useful for that. Ownership. Just because you forwarded that problem to somebody else doesn't mean that you're done with the problem. You should be trying to figure out what they managed to learn from the problem, and then also still be able to get back to root cause. Just because, you know, say like your core development team was involved doesn't mean that the problem ultimately laid in their domain. There might be a number of factors that cause the problem. In fact, usually with complex systems, it is a number of complex failures that causes the issue, not just a single one. Single point of failure reliability is pretty easy to try and ameliorate, but like once you've done that, then whatever remaining outages you have are probably due to multiple failures. And then finally, you'll notice, like earlier, oh, I actually skipped over. Okay, whatever. Finally, you know, being able to convince other people about what's going on using numbers helps a lot in terms of, you know, making your case and being able to, you know, figure out what the key issue that needs to be solved is. Okay, that's pretty much it. I've got some resources on these slides here, but websites that I like here, high scalability, articles by Afer, what he calls the Jepson articles. I'll provide the slides also online, so they should be available through the SCaLE website. But basically, Afer wrote a bunch of articles about why the distributed systems that exist today are imperfect, and you know, he basically treats each distributed system as he attacks them in a similar way to what security experts do for systems that need security, but he uses network partition failure simulation in order to try to get errors out of them that you wouldn't expect. Brendan Gregg's blog, so you guys all didn't go to his talk, but basically he has a lot of stuff about how to do performance troubleshooting. And finally, Server Fault is a great, you know, resource for just all sorts of stuff. And conferences I like. I haven't attended all these, but yeah, in person. But I've definitely gone to check out the videos for these various conferences. They give you a sense of what other people are thinking about and the hard problems that they're trying to solve. Finally, academic papers are still a great resource. It takes a little bit more getting used to that format and reading it, but there's a lot of stuff in the formal computer science world that hasn't made it into our sort of industry implementations just yet. All right, well, that's all I had to say, but I guess I was going to paraphrase a certain Disney movie and say, like, not everyone should be an SRE, but good SREs can come from any background. And I hope that that gives you some, you know, if you're looking to hire people as SREs, then think about that and figure out what are the key aspects of the SRE role that you want to identify and hire for. I've given some stuff, you know, a whole list of a grab bag of stuff that SREs find useful, but it doesn't mean that any given SRE should know all of them. In fact, it's practically impossible to know everything that you should know. But in general, having a breadth of knowledge and then really solid knowledge on one of these topics will go a long ways towards being able to sort of solve the problems that you don't know necessarily what they're going to be ahead of time. And having a mixture of people with diversity that have that depth in various categories of this, and then also having sort of the basic tool set will help you, you know, kind of weather through on-call, but also give you the tool set for figuring out the deeper problems where you need to escalate to just beyond whoever is on the rotation currently. Okay. So any questions? By the way, I've got some swag bags here, and we'll go to who asks questions first. Yes.
So, would you have any suggestions if you had somebody who wanted to train more into more of an SRE position from like a NOC or SA background?
Mm-hmm.
Is there any resources, that would help get them up to speed on dealing with more subtle issues or more complex behaviors and that sort of thing?
That's a great question. I would say that part of the reason I came up with this talk in the first place was that I was trying to come up with a curriculum. So like you can think of the stuff that I just the points that I just listed as sort of a study guide, but I actually want to get further into it and kind of maybe have like a wiki that would have independent, think of this as the knowledge map, and then you would have individual articles and pages about each. And it's just in addition to that, having sort of not a standardized test, but just a sort of questions that sort of probe whether or not you knew what you were learning would also be useful. So that's what I hope to develop next, actually. I think one of the things I need to figure out is how to do it in such a way that can be shared with everyone. Yes.
I would just like to point out that Unix is trying to focus more on that as well.
Yes. So.
And we've been running 3 SRE classrooms for Unix conference for the past year and a half. We're going to have a SRE in Santa Clara next month, and then go to Europe in May in Dublin.
Yeah.
Unix is trying to focus much more on the system engineering side of it.
Yeah, so there's the SRE Con that Unix is now holding. I don't have any personal experience with that one yet.
SRE Con, but we've done this at Lisa
Mm-hmm.
the past 2 years.
Yeah. So. Yeah, so that's good to know, because I know in the past when Unix kind of there was the System Administrators Guild. They had the Sage. They had the Sage sort of training set and stuff as well. That was more targeted to sysadmin, but now it sounds like they also have an SRE variant of that. Yeah.
And you can find Brendan Gregg's talks of the past 2 years.
Yeah.
He was talking about the various tools that here they are on the Unix side.
Mm-hmm. Well, you didn't ask a question, but.
I can ask a question.
No.
Are you on call?
Right now, no.
Right now, I sure hope you're not.
But
How you're on
this would be my normal on-call week, but I actually had PTO this week, so I could have been on call, but I just wasn't. Sorry, Ramras?
Yeah, I don't exactly have a question, but I wanted to thank you for the presentation. It does a really good job of covering like all the things.
Yeah, I need to work on the timing because obviously I went overtime.
What I wanted to mention was something that I'm with the Open Source Lab at Oregon State, and this year we're trying to teach the System Administration course at OSU again.
Okay.
I'm using that in quotations. And anyways, so we're trying
you have our
to
attention, but.
The response team has determined that there has been a false alarm.
I'm glad we got the alarm.
All right.
But anyways, we're trying to take a different approach in doing more DevOpsy. Like we started out with the basic system stuff in the beginning.
May I have your attention, please? May I have your attention, please? The emergency response team has determined that there has been a false alarm. We apologize for any inconvenience this may have caused you.
That's more inconvenience than me.
Yeah. Okay.
So we might want to collaborate or anything.
Yeah, sure.
We have how we've been sharing it is we also been doing a DevOps bootcamp thing at OSU to kind of get more students involved in DevOps. I hate using the term DevOps, but
I don't mind it.
But it's been a really great program because we can't hire all the students, but we want more students to know like the basic process. So we have a weekly 2-hour thing where we basically do hands-on stuff and we have talks about stuff, and it's been going really well. So we have that all on GitHub. It's in Sphinx doc. The DevOps Bootcamp site probably has more information. It's more entry-level stuff, but doing the Sphinx doc stuff on GitHub is so nice.
Yeah.
For sure.
Yeah. I don't mind the term DevOps, but I think there is a difference between that and what SREs necessarily are focused on.
Todd Underwood describes it as no ops.
What, sorry?
Todd Underwood.
Oh, yeah.
Describes it as no ops.
Yeah, well, there's also the term derp ops, which I think is more colorful than no ops, but yeah. Yeah. Mm-hmm.
I think you covered pretty good log aggregation stuff, config management, but thank you. I didn't notice one thing that in our organization SRE is in charge of. It's monitoring. What's the take?
Monitoring, yeah.
Do you think SRE should be responsible for monitoring systems, log aggregation, trending solutions, or it should be kind of?
That's actually a good point. I didn't mention any monitoring stacks there. That's probably an oversight on my part, but one of the reasons for that is just that there are a lot of different monitoring solutions there, and I couldn't necessarily name one that was good. So like different monitoring tools are good for different things, but I think a lot of the monitoring tools out there are still they're a little constrained on like how well they scale upwards.
No, I mean my question is not how to monitor. My question is, should SRE be monitoring the infrastructure, or it's not kind of?
Well, I think if you have a team that can develop the monitoring tools for SRE, that would be great. But in general, my experience is that because it's kind of sort of a sideline to your actual service that you're running and doesn't have a direct customer impact, that often it falls upon the SRE team to kind of use components that maybe some that are already open source, but then build something out of that. And that's sort of like what I mentioned, like Logstash, for instance, is like logging as well is sort of a sideline in general, unless you have specific logs that are very critical for your value add to your service. Like Facebook, for instance, gets a notion of what all their users are doing by figuring out what people are hitting, right? But
one way of putting it, it's useful to have someone develop monitoring tools, but SRE serve as the own monitoring because developers don't typically know what's important to monitor and what sorts of information needs to be monitored. SRE needs to know. Developers typically are not very good at that sort of insight.
Yeah, so Patrick makes a good point, is that oftentimes developers might not have the operational background to understand what needs to be monitored, and so SRE needs to at least contribute to that understanding. And that's another form of DevOps, is just that communication between the two groups and saying, well, in addition to, like, I run into this problem all the time, is like a particular microservice that is part of our application stack is telling us some of this information, but it's also not telling us the information that we need in a fashion that we can decipher, or trend in a way that would make sense to us. So, like, maybe I need specific, metrics that are based on geographic location rather than such and such. So there might be application-specific metrics that you need to ask for from your developers. But in addition to that, you need to find a pipeline that works reliably for you. Because if you don't have reliable metrics and logging, you're not going to be able to reliably debug any problem that comes along, right? So whether or not that specifically is implemented by you versus some other group, it's not really a big deal. But in general, my experience is that it's probably going to be the SRE group that will have to kind of step up and kind of say this is important and needs to be done, and possibly, here's the first prototype of it. Yeah. That said, in our organization, we actually were able to rely on our cloud computing group to provide the basic infrastructure, and we've just augmented it since then. Yeah.
My question is, what do you think the DevOps versus SRE, does that complement each other, or is SRE is a part of DevOps?
I feel like this is completely just subjective in my opinion, right? But I would say that DevOps is more common among smaller companies, in particular startups, where you only have enough people that the developers are basically doing the operations. So at that point in time, you're more concerned with making a service that works well enough and runs somewhat reliably, but not necessarily worried about the full scale out just yet. When you start getting enough customers where scale is an issue, where and enough paying customers are basically it's a big loss that you might lose a lot of money because you had an outage for an extended period of time, then the SRE role becomes more critical. And in which case, then you might start having a specialized team for SRE. That said, I mean, even a company like Google, SREs are actually broken into two categories: people who are concerned with hardware reliability more, and then people who are software engineers who happen with a specialization in reliability.
I think one other thing is DevOps versus SRE. Once a company reaches a certain size, developers tend to have more focused areas of expertise, where SREs have to have at least a reasonable awareness of everything. So, yeah, like they can't just know like some area of the service. They actually have to have some insight into the internal about everything. So, when you have DevOps, and they're spending their time writing code that's specific to some part of the system, and they have a deep understanding of that code, but then they may have no clue other than here's the REST interface to talk to this other part. So you kind of need a dedicated SRE that may not have knowledge of all the systems, but has at least a general understanding of how they work and how they interact with each other. Where developers don't tend to have that for systems that aren't directly related to what they work on.
Yeah.
I can speak for what I do, and I support 4 to 5 different developer teams that just interact together. They don't know what each other is doing.
Mm-hmm.
We have to
But
know
you have to know what they're all doing.
Yeah, exactly.
I
So.
have no idea how they do it internally. I know that they do something along those
Yeah.
lines.
So to rephrase things, you could think of like DevOps as a mentality for developers being more closely tied to operations, whereas SRE is kind of a focus on just reliability, and and it tends to be more cross-disciplinary because they have to be able to say, well, I'm not just fixing my piece of code, but I'm looking at all the code on the system in order to fix it, to avoid outages.
The other thing about SREs is organizations that are at the point where they need an SRE team probably need to give SREs a lot of influence on developers. So if an SRE has a particular issue that they want developers to concentrate on, they need to have the influence to actually get people to work on the issues SREs care about. So it's extremely important.
Yeah.
There's a particular issue that's bothering the SREs a lot that means it's probably an issue for the entire company.
Any other questions? That's it? Oh, yeah, go ahead.
Is there a way we can follow or contact
I haven't set up a website or anything, so just come up after the talk, and I'll give you my email address.